Hello, my name is Colin Blackburn and I'm a member of the OME team based in Dundee, and today I'm going to talk to you about import in OMERO, particularly from the command line and ways in which it can be extended. So an outline of the talk is, first of all, we're going to review existing imports in OMERO, how the system works, and we're then going to look at the three extension points, which are transfers, excludes and targets. And then finally we'll wrap up with a little bit on the wider import ecosystem, a few other ways that you can do imports. So a quick review of import in OMERO. This is a quick reminder of the managed repository, file sets and the basic import workflow. The managed repository is an area of the disk accessible to the server where uploaded files are kept in a structured way. The structure is definable by an import template, and this allows you to define the structure according to users, groups, and in addition there will also be a time-stamped subdirectory containing the original files that comprise of the image, and in addition to that there'll be a log file pardon me, there'll be a log file for that particular import. In addition, there are pixels directories which may contain historic data from before the OMERO 5 system, but will also contain things such as pyramid files that have been generated. And finally, a files area which will contain various associated files that may have been uploaded with images. The file sets idea is that bioformats will identify the files which comprise an import. And this could be several files making up one image. It could be a one-to-one image and file. It could be one file with several images, as in the SVS dataset, or it could be many files that result in many images. This is typical in various HCS formats. And the file set is something that needs to be kept together for the import to succeed and for any further inquiries on that imported image to work. So now looking at the import workflow. On the client computer, bioformats is first used to get the import candidates. That is the file set, the files that need to be dealt with as a single entity in order to import the image. Those files are then uploaded from the local file store to the managed repository. And stored in the managed repository in the structure we've seen before. Once the files have been uploaded, and there's a checksum involved here to make sure that the files in the managed repository are identical to the files in the data directory. Once that's passed, the image is imported, so the data is extracted from the original files using bioformats on the server to store in the database. And getting data out really just requires bioformats to be available on the server. In this case, to view images, bioformats is used to parse pixels, planes, tiles or whatever directly from the uploaded files in the original format and pass that information back to the client for viewing or analysis. In addition, obviously metadata can be pulled from the database relating to that file. Any metadata that's in our model. Other metadata could be pulled directly from the files. And if the user needs the original files in their original format, they can now simply be downloaded. Bioformats doesn't need to be involved in this, but the files can be downloaded from the managed repository to the local data store of some sort. So transfers. We'll talk about transfers, we'll look at an example, we'll look at what else is available, and then we'll look at the extension point where your own transfers can be added. So the example we're going to use here is called hardlink, and this is effectively using the transfer mode ln_rm, and this creates hard links between the original data and the managed repository. So in this case it's taking place on a single file system. The bioformats is used by the client to identify the import candidates. The hard links are created, so the managed repository then has links to the original files in the same location as the data directory. Again, that is confirmed using a checksum, that's fine. and then the image is imported again using bioformats to extract the metadata and put it into the database according to the model. What we can then do is delete. So if the files have been uploaded successfully and if the files have been imported successfully, then the server will remove the files from your local directory. In this case, it effectively means just breaking the links from the local directory to the original files, because with the hard link system the links still exist from the managed repository to the original files. And this obviously means that there is no data duplication in this case. So what else is available? Well, there's upload and import. That's the default that we looked at a few slides ago. There's upload and then delete the original files. There's a copy, which uses the native copy system for the operating system. And again, there's a delete option with that. There's a hard link we've just looked at. And then finally there's symlink and import, which obviously doesn't have a delete option. So the use cases here might be for upload, it's the data on a separate system or remote import. For the copy, it might be the data on the same system, but you're getting a lower network overhead because you're able to use the native copy system, which will do things more efficiently than the built-in OMERO upload system. For hard link, you could be looking at very large data on an OMERO server. And for something like SoftLink, it might be using Dropbox on an OMERO server where the files stay within the Dropbox system but are linked from the managed repository. And this is a quick summary using the CLI. If you use the advanced help option, you get a list of the options. One of the things you can see here is there is some class name, which is the user class that we can define as an extension point, and that's the thing we're going to look at now. Pardon me. So extending transfers, we create a subclass of the abstract file transfer. We then put that class, this is a Java class by the way, we put that Java class in our Java class path, and then we can simply pass it as a transfer option. One possibility here might be, for instance, using a move and change group. So you could use the native file system's move, and then you could change the modifications on that file to present someone removing the files from wherever they've been moved to. And there may be other options as well that people can consider for their own particular use cases and systems. Okay, move on to the next area now, which is excluding imports. And again, I'll look at what's currently available and then the extension point for excludes. Currently we can exclude duplicates from being imported based on a couple of different criteria. One is the file name, so this uses the name of the file itself, and it also uses the checksum. If those both match, then the second import will fail. Another one is using the client path. This excludes files based on the full original client path. This doesn't use the checksum and is obviously for particular use cases where it's the path that entirely determines whether it's the same file or not, rather than the checksum. And the way to extend excludes, again, is we can create a subclass of abstract file exclusion and then pass the exclude option. Again, is a Java class, and if it's in the class path it can be passed on the command line in such a way. So for instance, one way we might think about extending exclusions might be to allow duplicate files for users in certain groups, but in collaborative groups exclude duplicate files even if it's being the import is being attempted by a different member of that group, and this would mean there'd only be one copy of a particular import with it for that collaborative group. So import targets. So first of all I'll look at legacy targets, then what's available, and then the extension points. And import targets are a way of telling the system where we'd like the import to end up, which dataset or which screen. The legacy targets that have been around in the command line for quite a while are -D and -R for the dataset and the screen. You basically provide the ID there of the containers that have to be in the group that you are logged into in order for this to succeed. If you want to import into a dataset in a different group, you need to explicitly log into that other group or use the sessions CLI sessions command to move group before doing the import. So the new import targets, it's a much more flexible system using -t and providing a target, and I'll come on to the specifications there. And you can also obviously provide the longer form -- target. So the format is import the file -t and then an action or a class followed by an optional discriminator followed by a pattern. And I'll describe what each of these mean in the next few slides, but effectively this format applies for all of the different import targets. So what's available currently? Well, the classes and actions we have available is the dataset and screen, if we want to specify those, regular expressions, and then user-defined classes. The discriminators, well, depending on the class or the action, the discriminator can be the ID or the name, and in some cases it can be implicit, and hence you can omit it. So dataset and ID, this is a not so interesting case. So in order to import this image into the dataset with ID 2, we specify dataset :ID :2 as our import target. Because for dataset the ID is implicit, we can just reduce that to dataset :2, which is a form that we use across the CLI for basically outputting the creation of objects. So if you create a dataset, then the output you'll get is dataset :ID. So this can be fed straight into the import target. And both of these are effectively equivalent to the legacy one -d2. And exactly the same syntax applies here for screen and ID. A little bit more interesting is providing the name with the dataset. So in this case, if we've got a dataset named sample01, we can specify that as the target by using -t dataset :name :sample01. And this will import it into the dataset with that name. If the name doesn't exist, then if the name doesn't exist, then it will be created automatically. And again, the same syntax applies to screen and name. But what if there are multiple targets? Well, in that case we want to, so if there are multiple datasets with the name sample01, we may want to specify the most recent or the oldest, or a unique one, in other words only import if there is just one dataset of a given name, or we may want to create a new one regardless and ignore any existing datasets of that name. So this can then simply be added to the discriminator. So we just add the small qualifying character of plus, minus, %, or at to the front of name to specify whether we want the most recent dataset called samples, the oldest one called samples, only import into a unique, or create samples even if it does already exist. In the top three, the dataset would be created if it doesn't exist, regardless, because obviously there is no newest, oldest, or unique in that case. And again, the same syntax applies to screen and name. And quite a bit more interesting and much more flexible is using regular expressions. So in this case we provide a class action, an action rather than a class at the beginning. So we have regex and then :name for the name we want to extract. And then here we have a regular expression which uses a named group, container1, to extract the name of the target dataset or screen from the path. So here we're looking at the first directory or set of directories that follows images / up to the point where bioformats recognizes the files as existing. So this could include path1/path2, or it could just be a single path element depending on the structure of the directories at this point. So in this case it would be the dataset would be DV, because that's the only part of the path that exists between images and the file that bioformats recognizes. Again, the implicit part here is the name, so we don't need to provide the name on the command line, but you may need to put the regular expression in quotes depending what characters are used. And in this case the container1 could refer to either a screen or a dataset, and this will be resolved depending on the type of the file being imported as to whether it tries to target a screen or a dataset. And then we can also do the same sorts of things we did before. We can specify the most recent or the latest or unique, or create one anyway. And then a little bit of a more complicated example might be that if we've got a series of plates in this structure here where we're using week 1, week 2 to basically collect together different acquisitions, we can then use a regular expression of this form where we're also looking for path elements beyond the container we're interested in. So in this case it would resolve to two screens that are into two called week 1 and week 2 as the import targets. So a couple would be imported into week 1 and a couple would be imported into week 2 in this limited example. And the import targets again can be extended. So in this case you create a class which implements import target, which is an interface in the Java library, and then as before you provide the target as a fully resolved class name in your Java class path on the command line. One particular possibility here might be using a target to use something like a timestamp, so extract the date or the time and use that as the name of the dataset or the screen. Right, coming on to the final part of the talk, looking at the wider import ecosystem. I'm not really going to mention cron or bash here, but clearly given the things we've just talked about, you can actually use things like cron and bash to script solutions for various import problems, either by providing shortcut commands for doing a lot of the stuff we've just done, or by importing on demand depending on acquisition systems, or importing overnight, etc. What I will talk about is import for, which is importing on behalf of someone else, and then a little bit about Dropbox. Pardon me. So importing for, on the command line we're able to use the sudo option to import on behalf of someone else. So in this case we're importing for the user John, and the admin user Jane, or the owner if John and Jane are in the same group, she's importing for John. And as you can see, this allows someone to basically take on the role of an importer to get data in for somebody else. Dropbox, some people know about. It's a file system monitor to find newly uploaded files and run an automatic import as those files appear. It's under the OMERO data directory, and it uses a set of subdirectories with the usernames. It looks for the appearance of files. If a file appears, it waits a little while in case a companion file appears, and when nothing has appeared for a user-definable amount of time, which is default is 60 seconds, it then begins an import for that user according to the directory the files have been placed in. Files can be placed in subdirectories under users, and those subdirectories are also monitored. One possibility here now, given the things we've just talked about, is using transfers and targets within Dropbox. Pardon me. Dropbox can be configured in templates.xml. One of the things we can do there is configure the import arguments for Dropbox, effectively what would be passed on the command line, because under the hood Dropbox uses the command line importer. So here we might set the transfer mode to lnrm, so do a hard link followed by remove. And then we may use a regular expression to pull out the container name from the path. So here we're looking for Dropbox, then we're excluding the username, then we're picking out the next level folder as a container. And as you see, because it's an XML file, we have to use a slightly odd syntax to put in the XML syntax there. So this will then mean that we can have a user who creates dataset 1, dataset 2 underneath their user directory, and if the files are copied in using a normal file copy, then they'd been ported into datasets called dataset 01 and dataset 02. Pardon me. And as you can see, following that import, what we have here is a user who has those two datasets created with the necessary files imported. There's a lot more on imports on our website. You can look at follow the links in the original Reveal.js version of this talk on downloads. You can follow the links to the information about the managed repository, imports and file sets, in-place import, various import scenarios, and the latest information on the import targets. If you need to know more about how imports work in OMERO 5, you can look back at the talks given in Paris 2015 and Paris 2014. There are links there. And thanks to the import team, the wider OME team, and the user community, and also the project sponsors. If you need any more information at all about this talk, then please ask on the forums or our user lists. That information is available on our website. Thank you very much.